Okay, last class we have discussed about the okay last last class we have discussed about the what is condenser. Okay, what is condenser and what are the function of condenser. We have discussed about the what is actually what is condenser. Okay, in this okay, what is condenser? Condenser is a device in which steam is condensed to water at a pressure less than atmosphere. Okay, condensation is effect due to removal of latent heat from exhaust steam by using circulating cooling water. Thus, a condenser is basically a heat exchanger in which heat of the exhaust steam is transferred to the circulating water. Okay, circulating water. Okay, and we have discussed about the functions of condenser. Okay, the main function of the condenser is to decrease the exhaust pressure below the atmosphere and to provide hot feed water to the boiler. And also we have discussed the advantages of this condenser. Okay, higher pressure ratio provides larger enthalpy drop. Okay, work output per kg of steam increases, thus the specific steam consumption decreases. Okay, condensate can be reused as hot feed water to the boiler. As the feed water is hot, it reduces the time of evaporation and hence fuel economy. No feed water treatment is required, thus reduces the cost of plant. Okay, also we have discussed the elements of condensing plant, and also we have discussed the classification of condensers. Okay, mainly it is classified into two types, that is jet condenser and surface condenser. Okay, in this jet condenser is also known as direct contact type because in jet condenser water is in direct contact with exhaust steam. And also we have discussed the advantages of jet condenser. Okay, mainly the advantages are it is effective mixing, it requires less circulating cooling water, and equipment is simple and occupies less space. Maintenance cost is cheap. The disadvantages are not suitable for higher capacities. And also we have discussed about the surface condenser. Okay, surface condenser it is also known as indirect mixing type condenser. And we have discussed advantages of this surface condenser used for large capacity plants. High vacuum can be created. Okay, condensate is free from impurities and can be reused as hot feed water to boiler, and any type of water can be used as cooling medium. And the disadvantages are design is complicated and costly, high maintenance cost, and occupies more space, requires more circulating water. And we also discussed about the comparison of these jet condensers and surface condensers. Okay, the main different comparison is that in jet condensers it is directly contact, and whereas in surface condenser is not in direct contact. And it is simple design, less maintenance cost. Okay, whereas it is in surface condenser, it is a complicated design and high maintenance. Occupies less space, occupies more space. Okay, suitable for jet condenser, suitable for small small plants, whereas it is used for larger power plants. And also we have discussed the types of jet condensers. In these types of jet condenser, we have discussed three types of jet condenser. That is low level jet condenser, high level jet condenser, and ejector type jet condenser. In this low level, we have discussed again two types, that is parallel flow jet condenser and counter flow jet condenser. And also we have discussed about the high level jet condenser and ejector type jet condenser. Okay, now we will discuss about the surface condenser. There's the other type. The jet condensers are completed, and now we'll discuss about the surface condenser. Okay, surface condensers are widely used in large power plants. Okay, the common type are shell and tube surface condensers, inverted surface condensers, evaporative condensers, and regenerative type condensers. Okay, there are four types of surface condensers which we will learn, which we will discuss now. Okay, in this shell and tube surface, they have two types of condensers. That is a downflow surface condenser and central flow surface condenser. We have two types. Okay, first we'll discuss about the shell and tube surface condenser. First we'll discuss about the shell and tube condenser. Okay, now you can see on my screen, that is you can see on my screen there is a shell and you can see this is a shell and tube surface condenser. Okay, okay, it consists of steam, it consists of air and cooling water and a condensed. Okay, it consists a large number of tubes through which cooling water flows. Okay, it consists of large number of tubes through which cooling water flows. The steam to be condensed is made to flow around the tubes. The steam to be condensed is made to flow around the tubes. The condensated is free from impurities and can be reused as hot feed water to a boiler. Air is removed with the help of air pump in order to reduce the back pressure and improve the efficiency. Okay, this is the shell and tube surface condenser. Okay, once again I will tell you this shell and tube condenser. In this it consists a large number of tubes through which cooling water flows. The steam to be condensed is made to flow around the tubes around to flow around the tube. The condensate is free from impurities and can be reused as hot feed water to a boiler. Okay, air is removed with the help of air pump in order to reduce the back pressure and to improve the efficiency. Okay, this is the working of this shell and tube surface condenser. Okay, now we'll again discuss about this. In the second one, there is a downflow type. Downflow type. In this downflow type, also known as the cross section. You can see the cross section figure of this on my screen. There is a downflow type. Okay, this shows the sectional view. As you can see on my screen. Okay, this shows the sectional view. This is a sectional view of the downflow surface condenser. The exhaust steam enters at the top. The exhaust steam, you can see here, this is the exhaust steam enters from the top and enters from the top. Okay, enters from the top and flows downwards over the tubes. Flows down flows downwards over the tubes. Flows downwards over the tubes through which the cooling water is circulated. The steam is condensed and condensated is extracted at the bottom by condenser pump. The cooling water flows in one direction through the lower half of the tubes and returns in the opposite direction through the lower half of the tubes and returns in the opposite direction through the upper half of the upper half. Okay, the air extracted at a lower temperature by providing a baffle plate. Thus a small air pump is required to handle the air. Air pump is required to handle the air. This is the working of this downflow surface condenser. Okay, once again I'll tell you. Okay, you can see on my screen the sectional view of a downflow surface condenser. The exhaust steam enters at the top and flows downward over the tubes through which the cooling water is circulated. The steam is condensed and condensate is extracted at the bottom by condensate pump. The cooling water flows in one direction through the lower half of the tubes and returns in the opposite direction through the upper half. Okay, the air is extracted at a lower temperature by providing a baffle plate. Thus, a small air pump is required to handle the air. Okay, this is the working of this downflow type. Okay, downflow surface condenser. Now let's see the central flow type. Now let's see the central flow type condenser. Okay, in this central flow surface condenser, okay, you can see the cross section of the cross section of central flow condenser on my screen. Okay, in this case, air extraction pump is placed at the center. Air extraction pump is placed at the center and the condensate pump is situated at the bottom. The steam enters at the top and moves radially inward. The condensate then leaves at the bottom where condensate pump is located. Okay, in central flow surface condenser, whole periphery of tubes is used. Okay, whole periphery of the tubes is used, which provides better cooling area. Okay, once again I will explain you the working of this central flow surface condenser. Okay, you can see the cross section of a central flow condenser. Okay, in this case, air extraction pump is placed at the center and condensate pump is situated at the bottom. The steam enters at the bottom and moves radially inward. Okay, the condensate and then leaves at the bottom where condensate pump is located. In central flow surface condenser, whole periphery of tubes is used, which provides better cooling area, okay. This is the working of this down flow down sorry central flow surface condenser. Okay, okay, already we have discussed the first one, that is the shell and tube surface condensers. Now we'll discuss about the inverted surface condenser. Okay, in inverted surface condenser. Okay, in this inverted type surface condenser, in this case, steam enters at the bottom and flows upward. Steam enters at the bottom and flows upward. Air extraction pump is placed at the top. Air extraction pump is placed at the top. The condensate flows down and removed at the bottom where condensate pump is located. Okay, this is the working of this inverted type surface condenser. Okay, in this case, steam enters at the bottom and flows upwards. Air extraction pump is placed at the top. The condensate flows down and removed at the bottom where condensate pump is located. Okay, this is a inverted type surface condenser. Now next see about the evaporative condenser. You can see on my screen there is a evaporative condenser figure. Okay, it consists of the header and a steam in and a coiled tube and the condensate out, and we have the cooling pond. Okay, and from the cooling pond water is pumped through the uh, pump. Okay, okay, this evaporative condenser is used where supply of cooling water is limited. Okay, where supply of cooling water is limited. Okay, okay, you can see the principle of evaporative condenser. Okay, the exhaust steam from engine or turbine is passed through a coiled finned tube over which the cooling water is sprayed. Over which you can see the spray on my screen. You can see this is the sprays. You can see the sprays. Okay, okay, you can see the sprays. Okay, okay, in this. Okay, in this the exhaust steam from engine or turbine is passed through a coiled finned tubes over which the cooling water is sprayed. The part of water is evaporated. Taking the latent heat from steam, and the rest of water drips down to cooling pond. The evaporated quantity of water is compensated with fresh cooling water. Okay, with fresh cooling water. The condensate is recovered from the other end of the coil. Okay, the evaporator condenser are used in small plants. This evaporator and condenser are used in small power plants. Okay, okay, okay. Now I will once again I'll explain the evaporative surface condenser. Okay, the exhaust steam from engine or turbine is passed through a coiled finned tubes over which the cooling water is sprayed. The cooling water is sprayed. Okay, the part of water is evaporated. The part of water is evaporated. The, the part of water is evaporated, taking the latent heat from steam, and the rest of water drips down the cooling pond. The the evaporated quantity of water is compensated with fresh cooling water. The condensate is recovered from the other end of the coil. Okay, the evaporator condenser used small in small plants. Okay, okay, small plants. Okay, now let's see the last type is the regenerative type condensers. Okay, the condensers used in a regenerative method of heating the condensate are called regenerative type condensers. Okay, the condensers used in regenerative method of heating the condensate are called regenerative type condensers. In this case, the condensate after leaving the condenser is passed through the exhaust steam where its temperature is increased. The condensate, uh, the condensate at high temperature can be reused as feed water to the boiler. This increases the efficiency of the plant and minimizes the fuel consumption. Minimizes the fuel consumption. Okay. Okay, once again, I will tell you what is this regenerative type condenser. Okay, in this, the condensers used in a regenerative method of heating, the condensate are called a regenerative type condensers. Okay, in this case, the condensate after leaving the condensate after leaving the condenser is passed through the exhaust steam where its temperature is increased. Increased. The condensate at high temperature can be reused as feed water to the boiler. This increases the efficiency of the plant and minimize fuel consumption. Okay, this is working of this regenerative surface condenser. Regenerative surface condenser. Okay. Okay. In this class, till now we have discussed about the surface condensers, types of surface condensers. Inside types of condensers, we have discussed about the shell and tube condenser, downflow surface condenser, central flow condenser, and inverted surface condenser, evaporative condenser, and the last is the regenerative type condenser. Okay, in this mainly the vacuum. Okay, this is the mainly there will be a vacuum. Okay, vacuum in the condenser. Okay, the vacuum in a condenser is produced by removing air and condensate from the condenser. Okay, the vacuum in a condenser is measured by means of vacuum gauge. Okay, the measurement of vacuum in a condenser you can see on my screen. Okay, consists of barometer reading. It consists of a condenser and the absolute pressure and a vacuum gauge reading. Okay, actually, we know that the absolute pressure is equal to barometric reading minus vacuum gauge reading. Nothing but the absolute pressure, nothing but the barometric reading minus vacuum gauge reading. Okay, or in other way, we can say also vacuum in the condenser is equal to barometric reading minus absolute pressure. In that way, we can also be used. Okay, these are two ways we can calculate the vacuum pressure. That is the absolute pressure is equal to barometer reading minus vacuum gauge reading, or we can say the vacuum in the condenser is equal to barometer reading minus absolute pressure. Okay, okay. Actually, what is this corrected vacuum? Already say what is this corrected vacuum? Vacuum is referred to a standard barometer reading. That is nothing but the barometer reading is 760 mm of Hg. If the barometer reading not coincides with standard value, the corrected vacuum with respect to standard barometer may be calculated by using the relation. By this relation, the corrected vacuum is equal to a standard barometer reading minus absolute pressure in the condenser. Then that is equal to 760 minus actual barometer reading minus actual vacuum. In this way, we will calculate the corrected vacuum. Okay, in this we can also see the uh, vacuum efficiency. Okay, vacuum efficiency due to presence of air inside the condenser. Due to the presence of air inside the condenser, the actual pressure in the condenser is higher than the saturated pressure corresponding to steam temperature inside the condenser. Okay, the presence of air reduces the vacuum due to the increased absolute pressure. The amount of air leakages to the condenser is indicated by the volumetric efficiency. Okay, okay. Simply, we can say that the vacuum efficiency is defined as the ratio of actual vacuum in the condenser, actual vacuum in the condenser to the ideal vacuum is known as the vacuum efficiency, and the actual vacuum by the nothing but the maximum obtainable vacuum. Okay, actual vacuum by maximum obtainable vacuum, or simply we can say as the actual vacuum in the condenser to the ideal vacuum, or we can see in the barometer readings nothing but the in the other way we can also say the vacuum efficiency is equal to barometer reading minus absolute pressure in condenser. It is a barometer reading minus absolute pressure in the condenser to the barometer reading minus pressure at condensate temperature. Pressure at the condensate temperature. Simply we can say that the vacuum machine is equal to P bar minus P by P bar minus PS. Okay, in this way can say that this absolute pressure P is equal to PS plus PS plus PA. Okay, this is the vacuum efficiency. Okay, and we have some other efficiencies, the condenser efficiency. Okay, some other efficiency, condenser efficiency. Condenser efficiency indicate the effectiveness of heat exchange. Condenser efficiency indicate the effectiveness of heat exchange between exhaust stream and cooling water. Exhaust stream and cooling water. Due to presence of air, temperature in the condenser is less than saturation temperature. Okay, sorry, once again I will tell you. Okay, once again, the condenser efficiency indicates the effectiveness of heat exchanger between exhaust steam and cooling water. Due to presence of air, temperature in the condenser is less than the saturation temperature. Nothing that we can say Tg corresponding to absolute pressure in the condenser. Therefore, the outlet temperature of cooling water is always less than the saturation temperature, always less than the saturation temperature. Okay, simply we can say this condenser efficiency. Okay, the ratio of actual rise in temperature, the ratio of actual rise in the temperature of the cooling water to the maximum possible temperature rise, actual volume, actual possible temperature rise. This is known as the condenser efficiency. It is the ratio of actual rise in temperature. Okay, what is the temperature raised of the cooling water to the maximum possible temperature. Okay, up to the maximum possible temperature is known as the condenser efficiency. Okay, these are the following two efficiencies. Okay, and there will be the problems for this condenser temperature and vacuum efficiency. Okay, we'll discuss the problems in the next class. Okay, okay, today we have learned about the what we say, different types of jet condensers, surface condensers, and also we have learned about the efficiency, vacuum efficiency. We have learned the vacuum efficiency and condenser efficiency, and we'll discuss remaining topics in the problems in next class. And also we will learn about this what we say, we will learn, I will tell you the air extraction. What is this air extraction? Okay, what is this air extraction? To maintain the vacuum in the condenser, the air should be removed continuously from the condenser by using air extraction system, air extraction system. Okay, to maintain the vacuum in the condenser, the air should be removed continuously from the condenser by using air extraction system. Okay, in this air extraction, we have two types of air extractions. Okay, for removal of air from condenser, okay, we have two types of air extraction system. There is a dry air extraction system and wet air extraction system. Okay, first we'll learn about the dry air extraction system. Okay, in this system, air pump nothing but this dry air pump removes only air from the condenser, and separate pump is used for extraction of condensate. Okay, the dry air pump is connected at the top of the condenser, and its opening is kept away from the incoming steam to avoid mixing of steam with air. Okay, simply we can say as it will extract only dry air. Now next is the wet air extraction system. Okay, what is this wet air extraction system? In wet air extraction system, wet air extraction pump removes both the condensate and air from the condenser. The pump is connected at the bottom of the condenser. Okay, this pump is connected at the bottom of the condenser. Okay, this is the wet extraction system. This wet extraction system removes both the condensate and the air, from the condenser. Okay, it is connected at the bottom, whereas this dry air pump is connected at the top of the condenser. Okay, okay, this extraction system will require a pump. Okay, what is this function of pump? Okay, air pump. Simply we can say as the air pump. Okay, the function of air pump is to maintain a desired vacuum. The function of air pump is to maintain a desired vacuum in the condenser by removing the air. Okay, we have the removal of air is the main function of this air pump. Okay, we have two types of air pump, that is Edwards air pump and steam jet steam jet air ejector. Okay, we'll learn these two pipes in the next class. Okay, in this mainly in this chapter, the steam condensers, mainly in the exam point of view, we'll ask them mainly the state the function of condenser, to write the two advantages of jet condenser. Okay, define condenser efficiency, state the function of air pump. Okay, what's the difference between the jet condenser and surface condenser? Okay, why vacuum is maintained in the condenser, and list out any two basic types of condensers. Because these are all the one mark questions in the if you ask in the board of diploma examinations. And moreover, the essay questions will be explain the reason for using condenser in thermal power plants, and describe the classification of steam condensers, explain the difference between the surface condenser and jet condenser. Okay, and we'll ask the about the explain describe the working principle of Edwards air pump, and we'll ask the explain the working principle of evaporative surface condenser with neat sketch. Write detailed classification of steam condensers. Explain shell and tube surface condenser with a neat sketch. Explain the working of high level jet condenser with the help of neat sketch. Okay, in this way he will ask in the examinations. Okay, these are the types of questions in which he will ask in the examinations. Okay, next class we'll discuss about the air pumps. Okay, Edwards air pump and steam jet ejector. Okay, the main topics we will discuss in the next class. Okay, thank you very much.